Morning class, we are looking at section 4.7, optimization. Here's the summary of curve sketching when it comes to rational functions. Besides the old stuff, such as finding the intercepts, asymptotes, we add to it information from calculus to find intervals of increasing, decreasing, local extrema, inflection points, and so on. Now, optimization. In short, we are interested in things of the nature maximizing profit, minimizing cost, maximizing the area enclosed, and to do so we use calculus and the idea of optimization. Now, when we do that, a lot of times we end up with an open interval, in which case we are looking for a local extrema, and then whether it's an absolute or not. We do the first or second derivative test. We know how to do that. We're going to repeat the same thing, except when we have only one and one critical point, it is not only a local, also it's an absolute max or min. So here's an example to get us started. We have 2,400 feet of fencing, and we want to fence off a rectangular field that borders a straight river. So we don't need anything along that river. We want to see how we achieve the maximum area. So if you look at these figures, we just picked up numbers here and then for the length and width, did the math, see what happens. But this is not necessarily giving us the best choice. The best choice is to do math as follows. The length and the width, one of them is x, one of them is y. And so what is our objective, class? Our objective is to maximize the area. So what is the area? The width times the length, the x times y. Objective. What is our constraint? In other words, what is the limiting factor? Take a look. We have only 2,400 feet of fencing. So we are looking at the perimeter, which is normally 2x plus 2y. But in this case, it's 2x plus only 1y because we don't need anything along the river. Therefore, this is the translation, class. So the objective is to maximize the area, which is x times y, and the constraint is 2x plus y equals 2,400. So the process now becomes mathematical, in which case we are looking at a being a function of two variables. If we solve for y, becomes 2,400 minus 2x, and we replace it here. Now, it is a function of only one variable. Now, you always have to figure out the domain. The domain is what? Because it's a dimension, obviously, x has to be positive. Okay. Now, what else? If you look at the parentheses here, 2,400 minus 2x, when you set this equal to 0 and you solve, you get 1,200, which means if you pick a number larger than 1,200, makes the parentheses negative. You can't have that. Therefore, it gives rise to the domain being from 0 to infinity. 0 to 200, my apologies. 1,200. Okay. So now you have an open interval of 0 to 1,200. And do look for the critical point by differentiation. So if we differentiate this, we get 2,400 minus 4x. We set it equal to 0 to find the critical point. X becomes 600. We have a choice, the first or the second derivative test. I'm going to show you both. The first derivative test, as you recall, it was a sine graph. So you put the critical point here for x and the value of a prime here. And as you notice, here's how we get it. If you pick a test point to the left of 600, you can even pick 0 for testing. If you plug it into here, you get positive. To the right becomes negative, up and down, arrow up and down. That means Local max occurs at x equals 600. Okay, that's the first derivative test. But I hope you see why the second derivative test is easier. If you take the second derivative, you simply get -4. So what is the meaning of that when you get -4, class? Okay, -4 means concave down, looking like this. So the max occurs there. I hope you see that the second derivative test is easier. Of course, we are supposed to plug in the critical point into this a double prime because it is not a function of x, you don't need to. And so having said that, the choice is x equals 600. Then what do? We go back up here and find y either from here or here, 2400 minus 2x, and you put it in the area as well, and you find the dimensions. So y is 1200. So the maximum area would be their product, which is 720,000 square feet. In other words, any application problem, you have to make sure you answer the question properly at the end. We have a similar question. We want two numbers. So first and foremost, let's say x and y. We don't know the numbers. So the sum is 80 and the product is maximum. So our objective is to maximize the product, which is, let's say, p equals x times y. And the constraint is that the sum is 80, so x plus y is 80. And I hope you see it's very similar to the previous one, maximizing the product of two numbers. Same thing, p is a function of two variables. We're going to get rid of the y in the constraint, which becomes 80 minus x, and put it in there. So we get 80x minus x squared. We need to find the domain and look at what we want to achieve. We want to get the maximum. So that means we are hoping not to get 0. So x must be positive. We are hoping not to get any negative either, right? So x is larger than 0 so far. Now, if you look at this parentheses, if x is 80, it becomes 0. And if it's larger than that, it becomes negative. Therefore, we restrict it from 0 to 80. So one more time. Why 0 to 80? Because it says maximum. When it says maximum, we are hoping not to get a 0 or negative number. And because of this one, it creates a negative if we go beyond 80, and that is the open interval of 0 to 80. Notice it's open, which means it doesn't follow the closed interval theorem. You don't have to worry about the endpoints. We go through the process again, differentiation, 80 minus 2x. Set it equal to 0 and you get 40. Very straightforward. Is this going to maximize or minimize? Let's go with the second derivative test because p double prime is what? Negative. The idea is that p double prime is negative. Concave down. Maximum occurs when x is 40. You put it into x plus y equals 80 and you get the y. Their product, 40 and 40, 1600. Again, a similar question. Could somebody read this question for us, please? Could somebody read this, please?
A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek, as seen in the diagram. Find the maximum area that can be enclosed.
Fantastic. Thank you so much, Ethan. So look at the shape. So what is it that we want to achieve again? Maximum area. Okay, x times y. We want to maximize that. Now, constraint, we have how many feet? 240 feet of fencing. So how much do we need? Let's go with the formula. X, there's one here, another one here, another one here. So we have 3x, and y, which normally is 2, is only 1. So 3x plus y is 240. So area is x times y. Constraint 3x plus y equals 240. Okay, we do the same thing. We're going to solve for y, which means we're going to move the 3x. And again, restriction, of course, we want to maximize the area besides the fact that x has to be positive because it represents a dimension. Look at 240 minus 3x. When you set it equal to 0, you get 80, okay? And if you go with a number larger than 80, this parenthesis becomes negative. That's why it can't be, okay? Then the area becomes negative, which cannot be. So having said that, we multiply, finding the critical point, we differentiate 240 minus 6x. When we set it equal to 0, x becomes 40. Again, the second derivative test gives us negative. You don't have to evaluate much, just negative. So maximum occurs when x is 40. 3x, that means 3 times 40, plus y must be 240, that gives you y. And then x times y. So 40 times 120, those are the dimensions, and the area becomes 4,800 square feet. As always, we should write proper units class. Proper units. Okay. Now we have a box with a square base, an open top, volume of 32,000 cubic centimeters. We want the dimensions that minimizes the amount of material. Why do we want to minimize the material? Probably we want to minimize the cost. So let's first discuss rectangular solid in general class. Maybe I do the drawing here. By the way, what you see here, even x and h, it may not be to scale. So this is the height, width, length. The volume is LWH. The surface area is 2 times the base. The base is LW. Then there are 4 walls, okay. H times W, and then H times L. So you have 2 of each. Now the same thing works out here if we don't pay attention to open top for now. The base is x squared, there are 2 of them. The wall is h times x, and they're all identical, there are 4 of them. So it would be 2x squared plus 4hx. However, since it says open, then we have only one of those. That means 1x squared, not 2x squared. That's all, okay? And what is the surface area? So as I mentioned, x squared plus 4xh, and the volume is the area of the base, x squared times h is 32,000. So I wanted to remind you about a piece of geometry class, and I hope everybody's comfortable with that. So with that being the case, okay, information from geometry, the volume and surface area of a rectangular solid. Now what happens? Again, this has two variables, x and h. We don't like that. Let's solve for h. In the constraint becomes 32,000 over x squared. Now s is a function of x and h. If we replace the h with this, becomes a function of x only. And I hope you see that this one is 128,000. It's hard to see. Over x, because x and x squared, they cancel each other, they give us 1x. Now, 128,000 over x, we can write it as 128,000 x to the power of -1 for the sake of the next step in a moment, plus x squared. And if you look at this one, if you take a common denominator, x, then this remains unchanged, this becomes x cubed. I have both because I have a reason. I want to explain why we have this one, and then this one is for the sake of the next section, next step. All right. We want to find out the restriction on x. First and foremost, we know that we are dealing with dimensions, so x must be positive. Okay, that comes from there. But is there any other restrictions? When we look at this, this is a rational function. The only restriction is x can be any number except 0. So this is more restrictive. This will take over. Okay, x is larger than 0, which means we are looking at the open interval of 0 to infinity class. Okay, and so we got to differentiate. S prime of x is 120,000 times -1, makes it negative, x to the power of -2 plus 2x. Now, of course, we can take a common denominator as follows. Remember what this is, class. This is the same as negative 128,000 over x squared, right? Now, if you take a common denominator between these two, it's x squared, so this becomes 2x cubed. Why are we writing it in this format? We are looking for what? Critical points. How do we find them? If you have a fractional expression, the top is 0, okay? F prime, or in this case, S prime is 0. The bottom is 0, it doesn't exist. So when you set the bottom equal to 0, becomes 0, and it's not in the domain, so don't worry about it. When you set the top equal to 0, then you can see the answer by setting 2x cubed equals 128,000. Divide by 2, you get x cubed is 64,000. Take a root, becomes 40. Class x cubed is 64,000. And if you take a cube root, you get 40 centimeters. Is this going to maximize or minimize? Because all we did, we found the critical point. And because it's the only critical point in an open interval, whatever we decide on, it's going to be absolute. So with that being the case, you can go with the first or second derivative test. I'm going to show you how fast you can do the second derivative test. Minus 128,000 times -2 gives you positive 256,000 x cubed, and this gives you 2. Now, I hope you see that this means divided by x cubed, divided by x cubed. If I put 40, then 256,000 is positive, x cubed, 40 cubed is positive, this is positive, plus 2 is positive. Positive means minimum. Why? First, again, I want to quickly show you. Class, this is 256,000 over x cubed plus 2. When you plug in 40, you get a positive number. And positive number means what? When it's positive, means what? Concave up. Looking like that. So minimum occurs at x equals 40, everybody. Minimum occurs at x equals 40. Okay? So meaning what? Meaning you go back to x squared h. H is 32,000 divided by x squared, and you find h. So h is 32,000 divided by 40 squared, which is 1600, and it gives you 20. So those are the dimensions. And if you were to find the minimum amount of material, S is 4xh plus x squared. We need 4,800 centimeters squared. By the way, the question didn't ask for that, but you know, in case. All right, we want two numbers again. So immediately we're going to say x and y. Just choose anything you want, but you know, we are comfortable with those. We want this to be minimum now. What? The product. So that means x times y. We want to minimize it. Their difference is 18, so x minus y is 18. And by the way, if you do y minus x equals 18, that works. The number that you get is maybe your first number and somebody else's second number. It's not a problem. You're just looking for the pairs. Same thing. This is a function of two variables. We get rid of the y here. By moving it becomes x minus 18, put it up there. And so P is x times x minus 18. Now, we want to discuss the domain, and y domain is all real numbers. This is important. What are we looking for? We want to minimize the product class. Therefore, if the product is 0, is fine with us. If the product is negative, that's even better. So again, the product, we want it to be minimum. That's why this domain of negative to positive infinity works out, and it's fine with us. Okay, so having said that, the rest is easy. We repeat the same thing. P prime is 2x minus 18. Set equal to 0 and solve, x becomes 9. That's a critical point. Is it going to maximize or minimize? Depends on P double prime. P double prime is 2, which is positive, and therefore minimum occurs at x equals 9. You put it in here. If x is 9, okay, 9 minus what number is 18? Negative 9. Okay, so the idea is that one number is 9, one is negative 9, in any order is fine, and their product is negative 81. So the minimum product of negative 81. Could somebody read this question, please? Anybody want to read this for us, please?
I can read it. Example 6. Let us enclose a rectangular area of 288 feet squared, and then divide it into 3 equal sized pens with parallel sides. What dimensions will minimize the material needed?
All right, let's see what we want to do, class. If we look at this, we are going to minimize the material. What material? Well, X and Y. Let's see, X, how many? 1, 2, 3, 4 of them. So 4X. Y, how many? 2 of them. So we want to minimize the perimeter, which is 4X plus 2Y. Given that the area is 288, that means X times Y is 288. Okay, class? And so we're going to repeat the same concept. We always use the constraint to solve for one of the variables. In this case, Y becomes 288 over X, and we are going to replace it into the objective function. Objective function is 4X plus 2 times Y, which is 288 over X, and that gives you 576 over X, or 576x to the power of minus 1. The reason we do that is for the sake of next step. There is nothing about X except X must be positive, simply because it refers to a dimension class. So domain 0 to infinity. Okay, there is nothing else there, because you want to always look at your function, see what you get here. The only restriction here is that X can't be 0. So when you write X larger than 0, it covers this one. Okay, if there are other restrictions, you got to pay attention to. Okay, and so what do we do next? We are going to differentiate. We get 4 minus 576x to the power of negative 2. Now this is 500 minus 576 divided by x squared, is the same thing. Now, why are we writing it like this? So we can get to the critical points by taking a common denominator. This becomes 4x squared minus 576. Now, what are the critical points? Okay. The critical points are what makes the top and the bottom 0. If you set the top equal to 0 and solve, we will do it in a moment. We'll see the answer. The bottom gives you 0, and 0 is not in here. So you set the top equal to 0 and you solve. Okay. And so what happens? You get 4x squared equals 576. Divide by 4, and you get x squared is 144. Take a root, you get plus minus 12. You get 2 answers, only one of them is positive. So you have one critical point. The next one is the first or the second derivative test. And I hope you see why second derivative test is easier, because p double prime is, this goes to 0, minus 576 times minus 2 gives us 1152x to the power of negative 3. Now, 1152x to the power of negative 3 is 1152 over x cubed. Now, if I replace the x with 12, I have positive over positive, which is positive. So I don't even have to evaluate it. The idea is that you should recognize this is a positive value and y. You should recognize it's a positive value and y. And so having said that, when it's positive means concave up, and that means the minimum occurs at x equals 12. So we go back up here, x times y is 288, or y is 288 divided by x. So you divide 288 by x and you get y equals 24. So the dimensions are 12 by 24. So the minimum, okay. What dimensions will minimize the material? These are the dimensions. What is the minimum, material? P is 4x plus 2y. If you plug in x equals 12, y equals 28, it results in a total of 96 feet of fencing. Again, why would we want to do that? Perhaps we want to minimize the cost. All right. What is the minimum distance between the two functions? Well, you got to graph both functions. I'm assuming everybody knows how to graph them, okay? This is a basic y equals x squared shifted up by 1. And this one you can find the vertex x equals minus b over 2a, and it opens down, okay? I'm assuming we have the graphs, it's not a problem. Now, if we want a minimum distance, it would be a vertical distance class, okay? The question is which vertical distance? It could be from here to here, here to here, here to here. We have no idea where the x coordinate will be, okay? They both have the same x coordinates, y, because then it gives a vertical distance. So the closest distance would be a vertical distance, okay? A vertical line is closer than anything else, right? When you have 2 points, okay? And so they have the same x coordinates, all right? So what is the vertical distance? The difference in y, okay, class? So the y of the top minus y of the bottom, okay? The y of the top minus the y of the bottom. All right, so let's rewrite this. I hope everybody can see that this is minus x plus x squared, of course. Okay, we are distributing. And so what do? Sky is the limit. We don't know what x is, but x can be any number, class. We can write from negative to positive infinity because there is no other restriction. Any point will do the job, class. Any point will do the job along the x-axis, and we don't know that. So having said that, let's differentiate v prime for x minus 1 set it equal to 0, x becomes 1/4. Okay. Now, what is the fastest way to get to the answer? V double prime, because remember, x equals 1/4 is simply a critical point. We don't know if this is going to maximize or minimize. This is simply a CP, everybody, critical point. And so V double prime is 4, which is positive, makes it concave up, and therefore minimum occurs when x is 1/4. When that is the case, the minimum occurs at 1/4, okay? What is the minimum distance? Well, we said the minimum distance is V of x, or this one, so plug it into this. If you plug in 1/4, I'm gonna assume everybody can evaluate it. Plug in 1/4 into this function, everybody, and you find the minimum distance, okay? I hope everybody is clear on that. All right, we want to find the point on this curve or graph y equals square root of x such that it is the closest number to the point 3, 0. It is extremely important that we set it up, so a graph really is important. So we have the graph, okay? So we locate 3, 0, okay, which is here. And then the closest point on the graph, we don't know. You can pick any point you want, x, comma, y. But what is y? Square root of x. This is 3, 0. This is a point which we don't know the location. We're going to call it x, comma, square root of x, okay? Some point. It could be here, 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 anywhere. We don't know, somewhere. So we want the closest point. We say x, comma, square root of x. And we find the distance between these 2 points, class. Everybody remembers the distance formula, right? X minus x sub 1 squared. So x minus 3 squared plus y minus y sub 1 minus y sub 2 square root of x minus 0 squared under the radical. This is the distance formula, okay? Distance formula, everybody. All right, it is easier to work with d squared. So let's do that. So it's just because it's easier. If you work with d and you go through the process, you get to absolutely the same answer, except it takes a lot longer. Okay, everybody, we don't want to do that, but that's just as good. In that case, we have x minus 3 squared. This one becomes x. Now, I hope you know that we can differentiate it just the way it is, or we can simplify it to x squared minus 9x plus 9. If you want to differentiate it just the way it is, it's simple. By the way, yx is larger than or equal to 0. This is the domain of square root of x class. The square root of x has a domain 0 to infinity. Therefore, we don't know. Any number will do the job as long as it's within the domain. Okay? Any number will do the job as long as it's within the domain. So having said that, when we want to take the derivative, it's easy. 2 times x minus 3 to the power of 1 times 1, and then plus x gives us 1. Okay? This is simply 2x minus 6 plus 1, or 2x minus 5, and x becomes 5 halves. Okay? X becomes 5 halves. And so now, is this going to maximize or minimize? We don't know. Okay, let's find f double prime. I hope you see that f double prime is simply 2, which is positive. That means concave up. That means minimum occurs at x equals 5 halves. Okay. So we want to find the point on the curve that is closest. So if x is 5 halves, so x and square root of 5 halves, okay? The distance you can plug in, class. If you plug it into this formula, you find the distance, everybody. So absolute mean is d of 5 halves, which is square root of 11 halves. That's the minimum, okay? But the point has coordinates 5 halves and square root of 5 halves. So one more time, I want to make sure everybody understands the point as well as the distance. The distance you plug in here, 5 halves minus 3 square it, plus 5 halves square it, and it ends up being square root of 11 halves. But what is the pair? X comma square root of x, okay? The x is 5 halves, and square root of x is the square root of 5 halves, not square root of 11 halves, okay, class? Square root of 5 halves. Okay. All right, we want to find the area of a largest trapezoid that can be inscribed in a circle of radius 1 and whose base is the diameter of a circle. So if you go with basically the unit circle and inscribe this here, looking like this. So we are looking at the unit circle, okay, class? So this is your unit circle, okay? Trapezoid looking like that. And the base is the diameter of the circle. And we want the largest area for this guy, largest area. So first and foremost, what is the area of a trapezoid? 1/2 And by the way, those are the coordinates, okay, 1, 0, okay, obviously 1, 0 up here, 0, 1, and the rest of it, this is negative 1, 0, this is 0, negative 1, those are coordinates that we should know. So the area is 1/2 the height times the larger base plus the lowercase base, okay? And so if you look at this, shape, I hope you see the height is the same as y, okay? And then the base, for this guy, the base is what? 2. I hope you see that because the radius is 1, this is 2. But for the top one, x times 2. So the height is the same as y. I hope everybody can see that. The base for the top, the smaller base would be, this distance is x times 2. And for the larger one, this distance 1 times 2 or 2. So now you replace them, okay? And 1/2, we can cancel out the 2, we get y times 1 plus x. Now, we can continue with the same thoughts. However, remember what's happening. We know x squared plus y squared is 1. Therefore, y squared is 1 minus x squared. Now, we can take a root and replace it, but again, we have the same situation. It's just tedious. So why don't we deal with y squared? How do you deal with y squared if you deal with a squared? Okay, if you make this a squared and do the math, it works out absolutely the same. So a squared is y squared times 1 plus x quantity squared, and y squared is replaced with 1 minus x squared. So this is because it makes it easier. Okay, now x is between 0 and 1. I hope everybody understands why, because this is 0 and this is 1. Okay. The circle, okay, has a radius of 1. So there is no way that you can have x to be 1. X must be less than 1. It can't be, because let's say as x is equal to 1. That means it's here. We don't have a trapezoid. So I want to make sure everybody understands why x is less than 1. And then, of course, over here somewhere, pick somewhere here, in essence, the first quadrant, x must be between 0 and 1. So it's important to understand the domain whenever we do this type of problem class. Open interval. Open interval. So having said that, what happens next? Okay. We are going to differentiate. So to differentiate, we can use the product rule. 1 minus x squared, okay, gives you negative 2x times the second parenthesis. And the second parenthesis gives us 2 times 1 plus x to the power of 1 times 1 minus x squared. Okay, again, perhaps if you multiply the two class and put it in descending order and differentiate is faster. But I just wanted to show you, okay, if you want to use the product rule works. The bottom line is it is up to you how you want to do this, and it's not a big deal. You decide what you want to do. I can't emphasize this enough. So having said that, okay, if we go like this, okay, we can take out the 2 or negative 2, either way is fine. And you see 1 plus x squared, you see 1 plus x, we can take out 1 plus x. If you go this route, factoring actually is a tad easier, believe it or not. So let me show you how the factoring works. So you take the negative 2 out, you get the 1 plus x out. So from here, okay, we get x left and 1 plus x. So this is from this piece, everybody. That's the idea. So in other words, don't even look at the second piece, just this one. If you take the negative 2 times 1 plus x, then x is left times 1 plus x. And how about this one? This one you don't have a negative, so because you're taking negative out, you have to put a negative. 2 is gone, 1 plus x out, 1 has no bearing, and you have 1 minus x squared. So all you have to do, simplify the brackets. I hope you see it's x plus x squared minus 1 plus x squared. So this one is x plus x squared minus 1 plus x squared. So you get 2x squared plus x minus 1. And so I did that for the sake of factoring class. It makes it easier. And if you factor the second piece out, you get the following. So 2 is a prime number. You put 2 and 1, so 2x and x, and this is negative 1, so it has to be 1 and 1, one of them negative. When this one is negative, this one is positive, it results in the middle term of positive. So there are how many answers? Let's find out. This gives you x equals negative 1. This gives you x equals 1/2, okay? And this gives you the same answer, negative 1. There are 2 answers. But let's go back. X can only be between 0 and 1. So the only acceptable answer is 1/2. Negative 1 is out. And so we can find y. Let's go back here. Y squared is 1 minus x squared. Okay. So 1 minus 1/2 squared makes it 1 minus 1/4 or 3/4. So y is square root of 3/4. Square root of 3/4 or square root of 3 over 2. This is the same as saying 3/4 under the radical. Okay. So what about the y? What about the area? Okay, area is y times 1 plus x. So square root of 3/2 times 1 and 1/2 becomes 3/2. So we get, so this is 3/2, everybody, 3/2. So it's, let's just write it. That's how we get 3 square root of 3 over 4. 3 square root of 3 over 4. So find the area of the largest trapezoid. Area is 3 square root of 3 over 4. Okay. So where does it occur? When, if you want to write the pair class, x is 1/2, this is the pair, and y is square root of 3/2, this one. So that's the pair, that's the area. Hopefully everybody is happy. All right, let's see what happens here. We are interested in the following situation. A cylinder is inscribed in a cone. I hope you remember both shapes. The cone has a height of h and a radius of r. We want to find the largest possible volume of such a cylinder. So this is the shape class. Let's just make sure everybody understands what's going on here. Let's discuss that. So this is the cone, okay? So the radius is r, and here's the height. And here's an inscribed cylinder, okay? So if we call this distance x, just in general, and this distance y, then this distance becomes h minus 1. So first and foremost, the volume of a cylindrical shape, because we want to do what? We want to maximize the volume of a cylinder. So pi r squared h. So if we call this r, we call this h. H is the height of the cylindrical shape r is the radius. I want to go with the formula class, okay? So the volume is pi r squared h. I'm just reminding you of the formula such that in this case, r equals x and h, capital H, is lowercase h minus y. But again, pay attention to the fact that we are writing the volume of a cylindrical shape. Now we are replacing the r, capital R, with x, and we are replacing the capital H with h minus y, okay? And therefore, the volume becomes a function of x and y, okay? Now, bear in mind, h, lowercase h, is the height of a what? Cone, and it's fixed. Lowercase r is the radius of a cone, and that is also fixed, okay? So the variables are x and y. What's the problem? We have two variables, x and y. So how do we fix the problem? So if you draw this is the r, you are looking at the following similar triangle class. If you draw this and you just look at this piece, similar triangles, if you recall, the definition is corresponding angles are identical, corresponding sides are in proportion, okay? So if this height is y, the ratio of y to x, okay, is the ratio of the height h to r. Similar figures. Why are we doing that? Because we want to solve for y. To solve for y, multiply both sides by x. And now we can replace it here and it becomes a function of x and x only, everybody. Okay, so let's replace it. V of x is pi I x squared h minus, replace the y, and now pi x squared h, okay, minus pi h over r x cubed. I hope you see that that's just we are distributing pi x squared. And x can only be between 0 and r. Why is that? X is the radius for the cylindrical shape. It can never reach the radius of the cone. It can never reach that. But why is it that it can't be 0? Otherwise, there is no cylindrical shape. So it has to be larger than 0, but it can never reach the radius of a cone. So it's between 0 and the fixed value r. Let's differentiate. Let's differentiate. Okay. Pi h is fixed times 2x, so 2 pi hx minus pi h over r is fixed times 3x squared. All right. So we can factor out the pi and h and x. And this is what, so this is just elementary algebra class, okay? So pi hx times 2 minus 3x over r. Why are we doing that? Because remember, we are looking for critical point or points. Well, when we set this equal to 0, what happens? Either x is 0 or the parenthesis is 0. X can't be 0. Okay, x can't be 0. That's out. And if you set this one equal to 0, I hope you see that 2 minus 3x. Let me just write that. When you set this one equal to 0, 2 minus 3x over r equals 0, it gives you 2/3 r. Okay? And so the only acceptable answer is 2/3 r. So what do? You have to find v double prime and plug in 2/3 r. I'm going to leave that to you. V double prime. Okay, this is the second derivative test. If you think the first derivative test is easier, you can do that. So I hope you see that V from here. It's easy to do that. If you differentiate this class, you get 2 pi h. If you differentiate this, you get minus pi h over r times 6x. And if you plug in, it becomes negative. I'm going to leave it for you. So find v double prime and plug it in. And you'll see that the maximum occurs when we choose x to be 2/3 r. Okay. And so what is v of x? Replace it with 2/3 r. So we are replacing, okay, this one with 2/3 r. And we come up with 4 over 27 pi r squared h. Class, all of this is algebra. Assuming you guys can do that. So I'm going to quickly recap what I expect you to do. Number one, you have to show this is negative. That means you have to look at v prime, differentiate it again. Okay? And probably it's easier to use this part and differentiate. Then here's v of x. Okay. And if you factor it this way, you can replace the x accordingly and show that it becomes 4 over 27 pi r squared h. I'm assuming everybody can do that. These are all algebraic steps. Algebraic steps, you can do that. I have the answer for you. The intermediate steps are missing. Could somebody read this question, please?
A fence 8 feet tall runs parallel to a tall building at a distance of 4 feet from the building. What is the length of the shortest ladder that will reach from the ground over the fence to the wall of the building?
Thank you so much, Ethan. So this is what we have. This is the situation, class. So take a look at this. Okay, so that's the length. I hope you are following what's happened. So the angle that it makes here is the same as here. This distance is 4 and this is 8. I hope you see where we get those numbers from, okay? Here's the fence. Here's the fence, everybody. So we did the drawing. Here's the fence. So it's 8, okay? And the distance to this building, which is a tall building, is 4 feet. So this is 4. And when you do that, this becomes theta, this becomes theta. The two angles are the same. We are interested in finding L, okay? Where L is the sum of AB and BC. Class, L is AB plus BC. So in this triangle, we find AB because we have 8. In this one, we find BC because we have 4. So we are going to relate each one to theta and h, okay? So if you look at this one, I hope you see that sine theta is the opposite, which is 8 over the hypotenuse, which is AB, okay? If you look at this small one, cosine theta is the adjacent, which is 4 over BC. So take a look at the shapes. Sine theta, 8 over AB. Cosine theta, 4 over BC. Okay. So I hope you see this means AB is 8 over sine theta and BC is 4 over cosine theta. So 8 over sine theta is the same as 8 cosecant theta. BC is 4 over cosine theta is the same as 4 secant theta. What about theta? Take a look at the theta. Can it be 0? No. If it is 0, it's on the ground. Can it be 90 degrees or pi over 2? No. Otherwise, it will be parallel to the building. So that's why, again, this is important. This is your open interval. 0 to pi over 2. Okay, let's see if we can go through that. And this has some steps involved, which is all trigonometric. So let's quickly go over that. So we want to differentiate L prime of theta, or the LD theta. Okay. So 8 cosecant theta becomes 8 times cosecant is negative cosecant cotangent plus 4 secant theta 4 times secant gives you secant tan. And we have to set this equal to 0 and solve. So that means we can take this one to the other side. Everybody becomes positive, divide by 4. So again, we are moving negative 8 cosecant theta cotangent theta to the other side. We are dividing both sides by 4, and this is what we get. So what is secant theta? 1 over cosine theta, okay, times tan theta. All right, so what is cosecant theta? 1 over sine theta. What is cotangent theta? 1 over tan theta. So take a look at what we are going to do. As it appears, we can use tangent. So secant, we change it. Cosecant, we change it. Cotangent, we change it. Okay. Now, I hope you see that if we want to get rid of this, we bring the tangent to this side, becomes tan squared. So if you drop this, this becomes tan squared. If you bring the sine to this side, sine over cosine is another tangent, that gives you tangent cubed equals 2. Okay, perhaps, let me see if I want to show this. So in other words, do I have room here? So on the left side, let's see, maybe we have here. On the left side, we have a 1 over cosine theta, tan theta, okay. So the sine theta on the right goes to the left, becomes this. So we multiply both sides by sine. And then tan theta on the right goes to the left, becomes another tan theta, and number 2 remains. I hope you see that. So quickly, this sine, I'm going to move it to the other side, and this tangent, I'm going to move it to the other side. Sine over cosine, these 2 give us 1 more tangent, 2 and 3, so that's why we get tan cubed. So tan theta is cube root of 2, tan theta is cube root of 2, and theta is tan inverse of cube root of 2, which is about 0.9 roughly radians. Okay, class? So I hope you understand what's happening here. Okay. Now, we can do the first or the second derivative test. I hope you see that the first derivative is difficult enough, so we don't want to go with the second derivative. So we do the first derivative test as follows. The minimum is happening at tan inverse of cube root of 2, which is, again, we found it to be 0.9 radians. Why is that? If you do the first derivative test, the LD theta, okay, this is theta, when it's tan inverse of cube root of 2, which means 0.9 radians roughly, the LD theta becomes 0, okay? If you pick a number to the left and right, by the way, they do alternate, you can check it. To the left, I hope you see that cube root of 2 is, just as an example, larger than 1, okay? And 1 gives you what? 45 degrees, okay? So if you plug in 45 degrees here, minus 8 cosecant of 45 degrees, cotangent of 45 degrees, and so forth. I hope you remember that for 45 degrees, tangent and cotangent are 1, okay? Sine and cosine are square root of 2 over 2, and cosecant and secant are the, inverse. So if you plug in, as an example, class, try Here theta equals pi over 4, and you see it becomes negative, okay? Because again, pi over 4 is a common arc, you're supposed to know that. And that shows, this is the answer. So what is L of theta, class? You are going to replace it, meaning 8 over sine of 0.9 plus 4 over cosine of 0.9 radians. Use a calculator, you get 16.65. This is done. I'm showing you the precise answer. I want you to again look at that and follow. If you can follow the concept you're comfortable with, trigonometry. If not, just stick with what we just did. So one more time. What is the length of the shortest ladder? L of theta. Replace the theta with 0.9 radians. 0.9 radians. And we go with sine and cosine. So you're done. The question is finished, okay, class? However, because 1 plus tan squared is secant squared theta, okay? And tan is sine over cosine, or secant over cosecant. I hope you can figure this out on your own. And cosecant is secant over tan. You can use these identities to replace this and take a look at what happens. This would be the precise answer using the fact that you're dealing with tan inverse of cube root of 2, okay? So I'm going to leave it for you to figure this out. Okay, I have done most of the parts. Again, do you have to go this route? By no means. But if you can follow that, your knowledge of trigonometry is good. I want to move on because we have a lot to do, class. So make sure you look at this and see if you can follow that. If not, this is fine, class. Although again, this is your information from trigonometry. Could somebody read this question for us, please? Anybody want to read for us? All right. A woman at a point on the shore of a circular lake with radius 2 miles wants to arrive at the point diametrically opposite on the other side, okay, of the lake in the shortest possible time. So what are we minimizing the time? She can walk at 4 miles per hour and row at 2 miles per hour. So how should she proceed? So it's important to understand that the different speeds are involved, okay, because of the rowing versus walking, okay. So let's see what happens here, okay. So we are going to, let's say, row here and then walk here. So AB and BC. By the way, BC would be the arc, S equals R theta. So first of all, this is 2 theta because it's a central angle. I hope you realize if this is theta, this is 2 theta, okay? This is a central angle, okay? Against the same arc, or you can look at this one plus this one equals to, this is the exterior angle for this triangle, and these two are identical because it's an isosceles triangle. However you want to put that, it's a piece of geometry along with trigonometry you should know. So this is 2 theta, okay? So we are looking at this triangle and this is a 90 degree. The reason it's a 90 degree because this is opposite the diameter, which is, this is what, half of, this is 180 degrees. It's half of that, or it's 90 degrees. This is a piece of information from geometry again. Okay, so we know this is 90 degrees, and therefore we can find, if this is theta, we can find sine theta, cosine theta, and so forth. So if we are going to go this way, okay, so cosine theta is AB divided by AC, and so we can use cosine theta to find AB. And BC, as I said, S equals R theta, okay? Now R is 2 and theta happened to be 2 theta in this example. So I hope everybody remembers what I'm talking about. Okay, so cosine theta, everybody, cosine theta is AB over AC, where AC is 2 plus 2 is 4. Class? AC is 4. If we do the cross product, AB becomes 4 cosine theta. Okay, AB becomes 4 cosine theta. That's rowing. Okay. All right. What about walking? We're going to walk here. And this is R theta. S equals R theta. What is R here is 2. When we say theta, we mean the central angle. The central angle happened to be 2 theta. I'm writing S equals R theta. This theta is not the same as the other one. This is reminding you of the arc length class, okay? From trigonometry. This theta is referring to 2 theta, is referring to the theta that is the central angle. So 2 is the radius, and 2 theta is the angle of interest, and therefore 2 times 2 theta is 4 theta. Maybe, you know, if we used alpha, just for the sake of argument class, if we had used alpha here, and 2 alpha here, and therefore 2 alpha here, maybe it would have made it easier to follow. But, and in that case, all of this becomes alpha, and you know, because I want to make sure that you understand this theta. Again, this theta that is referring to central angle is not the same. Okay, now what are we going to do shortest time possible? So remember, we have the distance divided by the rate gives us the time. For walking, 4 miles per hour. For rowing, 2 miles per hour. So I hope you see that we want to minimize the time. So for walking, we divide by 4. For rowing, we divide by 2. Okay. I hope you understand why we are dividing by those. And we get 2 cosine theta plus theta. Why 0 from pi over 2? I want to make sure that everybody understands why the endpoints are included. Simply because, what does it mean if theta is 0? That means we are going from A to C, we are rowing. What does it mean when theta is pi over 2? That means we are just going to walk. Is it possible that you do those? Yes, it really depends on your speed. If rowing is fairly fast, maybe you want to stick with rowing. If the walking is fairly fast, you want to stick with that. If it is in a manner that somewhere in between it works, so be it. And so let's do t prime of theta. Minus 2 sine theta plus theta, and we are looking for critical point. Set it equal to 0, and you get 1/2, and theta becomes pi over 6. This is a closed interval theorem, class. This is a closed interval theorem, and here's the function which is continuous from negative to positive infinity. So you got to plug in 0. You got to plug in pi over 6. You're going to plug in pi over 2. You have to plug in the endpoints. I'm assuming everybody can see that when we plug in 0, we get 0 here, and then 0 here. Cosine 0 is 1 times 2. If we put pi over 6, cosine of pi over 6 is what? Square root of 3 over 2 times 2 makes it the square root of 3, and theta is pi over 6. Precisely, and because when we compare, we go with the decimal representation roughly. If we plug in pi over 2, okay, let's see what happens. Pi over 2 cosine is 0. So that's out, plus pi over 2. What is pi over 2? We get 1.57, because it's, and this is a rough class, 3.14 divided by 2. You don't have to go with more decimals. We are just estimating. Obviously, this is the largest number, okay? Okay. and this is the smallest number. What do we want? Let's go back. Shortest possible time. Shortest possible time. Okay, so minimum is when theta is pi over 2, and the minimum value is equal to pi over 2 precisely. Okay, so she should basically walk. Okay, class. All right. From a thin piece of cardboard 8 by 8, square corners are cut. We fold them up into a box. What dimensions will yield the box a maximum volume? First, explanation as to what's happening, class. Okay. What we have is an 8 by 8. We are going to cut the corners by x. That means we're going to cut equal corners. And when we do that and we fold them up, what is left is 8 minus 2x on each side and the height of x. So what is the objective? We want to maximize the volume. Remember, the volume is the area of the base, the width times the length times the height, where the width and the length are both 8 minus 2x and the height is x. Okay. Replace them. Everything is a function of x. When you square this, you get 64 minus 32x plus 4x squared. Multiply by x. And why is it that x is between 0 and 4? And that's always important, class, having proper domain. Because obviously, as you can see, dimensions must be positive, so it's larger than 0. Remember, if you cut the 8 in half, you get 4. And if you cut it in half, there is nothing left to give you a volume. Okay, so 8 minus 2x equals 0. If you go with 4, that makes it 0. If you go beyond 4, that makes it negative. And so multiplication gives you that. Now, v prime is 12x squared minus 64x plus 64. We can factor out the 4. Four times 3x squared minus 16x plus 16. We can factor that as follows. I'm hoping everybody's comfortable with the factoring. There are two CPs. And when we look at the domain, 4 is out. This is out. The only acceptable answer is 4/3. This is a critical point. Is it going to maximize or minimize? We don't know. We have to go with the first or the second derivative test. V double prime is 24x minus 64. And if you replace it with 4/3, you get negative 32 because 3 and 24 cancel each other. 8 times 4 is 32 minus 64 is negative. So because it's negative, it's concave down, maximum occurs at x equals 4/3. Now we go back up here. X is 4/3. 8 minus 2 times 4/3 would be the width and the length. Becomes 16/3. And we are finding the volume by multiplying all of it. So again, we go back to 8 minus 2x. Replace the x with 4/3. We get to the answer. Okay. A store has been selling 200 flat screens. Flat screen TVs at a week at $350 each. A market survey indicates for each $10 of rebate offered to buyers, the number of TVs sold will increase by 20 a week. Find a demand price. Demand is the price function. And the revenue function, how large of a rebate should we give to maximize the revenue? There are two ways to handle this. You can look at the second method. I put it in the next page, but here's one way. We are looking at X and P of X class. Lowercase p represents the price, okay? So when we sell 200 pieces, that means 350. When we sell 220, okay, it's 340, okay? So I want to make sure everybody understands how we get that. Look at this one. It says the number of TVs sold will increase by 20. So if I increase it by 20, 200 becomes 220. Then the price has to go down by 10, 340. So I'm using this 20 and 10, and I change those two numbers to give me the second pair. So one more time. The first pair is given, everybody. The first pair is given. What about the second pair? I'm going to subtract 10 from the price. I'm going to add 20 to the number of pieces we are going to sell. Now I have two pairs, y minus y1 equals m times x minus x sub 1. I calculate the slope. And again, class, this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, okay? Or you can say p sub 2 minus p sub 1 over x sub 2 minus x sub 1. That's absolutely fine if you want to go with x and p, so this is p sub. And then y minus y1 becomes p minus p1, p minus p1. Let me just write this at top of it. So this in essence is p minus p1, okay, class? And so you do the math, you end up with the price. I'm assuming this part, class, is elementary algebra. You're doing your elementary algebra to find the equation of a function. What is the revenue? Revenue is the number of products, X, times the price. Now we are in business. We want to maximize this. We're going to use the calculus. So I hope you see all of this is algebra, class. Finding the price function is algebra. Finding the revenue function is algebra. How do we maximize this? We know how to do that. R prime minus 1/2 times 2x plus 450, set it equal to 0. X becomes 450. Easiest way, doing the R double prime. R double prime is -1, which is negative. The second derivative says it's negative. So the maximum occurs when X is 450, okay? So what is the price, everybody? What is the price? Plug in 450. The price will be 225. What would be the amount of rebate? Well, we were selling it for how much? $350, okay. Now 225. So the rebate is 125. So one more time. X equals 450. Put it in here. And that's a price. But the price was originally 350. So what is the difference? The amount of rebate.